Hello everyone, it's Mr. Salimata over here, and in today's lesson we'll be looking at area of two-dimensional shapes. In this lesson we're going to cover the area of a parallelogram, a triangle, trapezium, rectangle, and a rhombus. And by the end of this lesson, every student should be able to recognize these 5 two-dimensional shapes and be able to find the area of these shapes. Yes? Okay, so now let's get into our lesson. Yes? If we look at our whiteboard over here, I have drawn 5 two-dimensional shapes, right? But before we move along, I have a question. What is it that is common in these 5 two-dimensional shapes? Well, I'm sure some of you will give me an answer of like, well, the inside part is shaded of all of these shapes, right? Yes, that's right. But then, is there any other common thing between all these 5 shapes? Well, they are all two-dimensional shapes, right? They're all two-dimensional shapes. But then in our mind right now, we're asking ourselves, but then why has Mr. Salimata shaded the inside part of these two-dimensional shapes? Well, the reason why I've shaded the inside part of these two-dimensional shapes is because this shaded space that you can see in all of these shapes is the area. So then what does that tell us about the area? Yes, what is area? So area measures the amount of space inside a 2D shape. I'll say that again. Area measures the amount of space inside a 2D shape, and it is measured in square units. Yes? Okay, so then how do we find the area? Yes? Let's take a look at a small example, yes? Or a small illustration, yes? So let's try to draw a square. Yes? Let's try to draw a square. Yes? Let's draw a square. Yes, so we have a small square over there, and let's give it a unit of 1. Yes, let's give it a unit of 1. So we have 1 unit over here, 1 unit, yes, and 1 unit, 1 unit. And so then, how can we find the area of this square here? Yes, so since we said area measures the amount of space inside a 2D. So then the area of this square unit is what? Is 1 unit squared, right? So the area will be what? Will be 1 unit squared, right? Okay, let's try to look at another illustration. Yes? So let's say we have, let's have a rectangle. Yes? Let's have a rectangle. Now, in this rectangle, I want us to try to fit squares in it. Yes? Let's fit some squares in it. Yes? Let's say, let's fit some squares in it. Yes? Okay, so there we go. We have squares in this rectangle. Now, one thing that you have to note is that each square in this rectangle represents 1 square unit. Yes? Each square in this rectangle represents 1 square unit. Yeah? So then, how do we find the area? So we're talking about the amount of space, right? So all we have to do is we just have to what? To count the what? The square units in this rectangle, and we'll be able to find the area, right? So let's count them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. right? So the area of this rectangle is 18 units squared, right? So that's our area, 18 units squared. Yeah? So then, from this explanation and illustration, we can say that area comes from counting the square units, right? Yeah, so we can say that area comes from counting the square units. Yeah? Okay, so we have to ask ourselves a question then. How then are we going to find the area of a triangle, trapezium, parallelogram, a rhombus, a circle? Do these square units fit in all these shapes that I've just mentioned? Well, let's see. Yes, let's see. So let's take, for example, a triangle. Yes, let's go with a triangle. And let's fit, yes, let's fit in our square units. Yes, okay, these are our squares. Yes. Okay, so if area comes from counting the square units, that means it should be easy for us to just count these square units in this triangle, right? And we'll be able to find the area. But there's a catch here. If you see the squares in this, the square units in this triangle, you will find that there are some that are complete, yes, that are full squares, right? And then some that are half. So in order for us to count all the squares, we'll probably have to get, we will be able to count all the full squares, right? But then these other ones here on the edge, like this one is half. That means we have to put it with this one, then we'll consider it as one. Yes, one square unit, right? But that would take us a lot of time, yes, and probably even a little bit difficult for us to just recognize which half of a square that we can put together in order for it to be a square unit, right? So then, how do we go about finding the area of a triangle, a trapezium, a rhombus, a parallelogram, a circle? Yes? That is the reason why, yes, that is the reason why we have formulas. Yes? So we have formulas to help us find the area of these shapes. So now that we've got a concept of what area is or what it is about, let us now try to do some examples in order for us to get the knowledge on the formulas and how to use them to find the area of these 5 two-dimensional shapes that we are learning about today. Yeah? Okay, so now let's get into looking at some questions. Yes, so we can find the area of these shapes that I've drawn on my whiteboard over here. And remember, I did say that we have formulas, yes, to help us find the area of these shapes without the need of counting the square units. Yes. Okay, so our first question here, if we look at the shape, this is a rectangle. So what formula do we use to find the area of a rectangle? So the formula that we use to find the area of a rectangle is area equal to the length multiplied by the width. Yes? So this right here is the length, and this right here is the width. Okay, so this is the formula that we use to find the area of a rectangle. But you can also use this formula, yes, area equal to base multiplied by height. Yes, so this over here is the base, and this right here is the height. These two formulas are the same. Yes, so in our case, if we look at this rectangle over here, this right here is the length and this is the width, or this right here is what? Is our height, and this right here, which is also like the same there, is our base. Okay, so we can use any of these formulas. You can choose to use length multiplied by width or base multiplied by height. That's completely fine. Yes, okay, so now let us find the area of our first rectangle over here. Yes, and we say that the area is what? I'm going to use the first one, length multiplied by width. What's our length? Our length is 18 and our width is what? Is 7. Therefore, our area for the first one, 18 multiplied by 7, gives us what? 126 centimeter squared. 126 centimeter squared. Please note that. Yes? Okay, so now we have found the area of our first rectangle. Let us try to find the area of our second rectangle over here. Yes? Okay, so we already know the formula is area equal to length multiplied by width or base multiplied by height. That's totally fine. Yes? Okay, so our area will be what? What's our length in our case? Our length is what? Is 6, right? And what's our width? Our width is 4. So therefore, our area is what? 6 multiplied by 4, that gives us what? 24 centimeter squared. Yes? Okay. So that's how you find the area of a rectangle using this formula over here. But we can also prove that this formula is actually right by taking you back to what I said, to say the area, yes, the area comes from counting square units, right? So let's just try to prove this this formula right here. So let's say we have, I hope you guys can see. So let's draw a rectangle. Yes, let's draw a rectangle over here, and let's just try to put in these square units in it. Yes, like that. Now remember, we have to count, yes, to find the area, right? 1, 2, 3, 4, 5, 6, 7, 8, right? So the area of this rectangle that I've just drawn with 1 square unit each is what? Is 8 units squared, right? Okay, so then let's count. We have 1, 2, right? We have here 1, 2, so this side is 2, right? And then we have 1, 2, 3, 4, this side is 4. Now using the formula, all we have to do is to what? To multiply, yes, area, the length multiplied by the width, right? Our length is 4 and our width is 2. Therefore, the area will be what? 8 units squared, right? So you see, this is the proof that the formula that we are using, or rather the formula that was formulated is actually true. Yes? Okay, I hope you guys have got the concept. Yeah? Okay, so let's move on to finding the area of a triangle. Yes? So we have 3 triangles over here. Yes? Okay, so the area, or rather the formula to finding the area of a triangle is, I'll write it here. Yes. Half BH. Yes. And remember, from what I just explained over here. B is what? Is the base. H is the height. Yes? And we have our half in front over there. So it's half BH. Yes? And so for us to find the area of our first triangle over here, yes, which one is our base? Our base is this one right here. And our height is this perpendicular height over here. Yes? That is forming a 90-degree angle. Yes? Perpendicular height, yes, forming a 90 degrees angle. That's the height we're supposed to use. And this right here is the base. So therefore, for our first question, yes, we can then say that area, yes, is what? What's our base? Our base is 8, yes. We're multiplying everything, yes. And our height is 3, right? Now, there are two ways in which you can solve this question, yes. You can either multiply these two, yes, let's do that. Let's try to deal with these two terms, yes. 8 multiplied by 3 is what? Is 24, right? Now remember, we still have our half there, right? We still have our half there, yes? And if we do the division, that will give us what? Our area will be what? 2 into 24 is 12. The units we're using is what? Centimeter squared. So this is the area, yes? 12 centimeters squared. But another way is you can do the calculation right here by saying 2 into 8, yes? Right here. I'll do it just below here. So we can say, I'll just do that, right? 2 into 8 is 4, right? And 4 multiplied by 3 is what? Is 12 centimeter squared. So any of the process that works for you is fine. You still arrive at the same answer. Yes? Okay, so the area of our first triangle over there is 12 centimeter squared. Yes? Now let's look at our second question. Yes? The area of this triangle right here. Yes? So we already know what the formula is. Sorry, I forgot to just write the area. So we know that the area is half base height. Yes? And we know that our base, yes, our base is what? Is 5 centimeters. Yes? And our height, perpendicular height over here is what? Is 8. Yes? So then what will that give me? I'm just going to cancel it over here. 2 into 8 is 4, right? 4 multiplied by 5 is 20 centimeter squared. Yes? So this is the area of our second triangle over here. Yeah? Okay, let's get to finding the area of our third triangle. Yes? Okay, so now if we look at this triangle, yes, if we look at this triangle, it has this side here, the longest part, which is 16 centimeters. And then we have this dashed or rather dotted line, right? That is coming from the top vertex over there and touching the base. And what? Making a 90-degree angle there. So this right here is a perpendicular height, right? And then we have this side, which is the longest, the sloping side with a length of 16 centimeters. And then we have this down part over here, bottom part over here. That is the base, which is 24 centimeters. So then how do we find the area of this triangle? We are using the same formula. Area equal to half base height, right? Okay, so then our half is there, yes. So what is the base? Our base, we already know, it's this one here, 24. Yes, 24. That's our base. Our base is 24 multiplied by. Now, here is the thing. What is our height? Is it 16 or 15 centimeters? So our height Yes, our height is, like I mentioned at the beginning of this question, this perpendicular height over here. That is what? Forming a 90 degrees. So our height is 15. And when you meet such a question, please do not use this sloping side as the height, even if it's the longest. Always go for the perpendicular height that is forming a 90 degrees. That's the height we are supposed to use. So we are going to use 15. Yes? And then we can just work it out. So 2 into 24 is what? Is 12. Right? And 12 multiplied by 15, that gives us what? 180 centimeter squared. So this is the area of this triangle over here.